Hello, I'm Jed Sundwall, Executive Director of Radiant Earth. I wish I could be there with you in person, but I couldn't make it this year. That said, I'm very grateful to ESIP and to Chris Stoner for giving me the opportunity to talk with you all today. I've called this presentation, What Do We Do with All This Data? And to give you a sense of the volume of data that's being produced these days, I like to share this quote. This is from a book called Analogia by George Dyson, where he says, the digital universe is currently expanding by some 30 trillion transistors per second, populated by unbounded, if countable, strings of code. Now, these kinds of figures are hard to fact check, but I'm pretty sure he's right about this. And I'm also pretty sure that since this was published in 2020, that the number has only gone up. We are relentlessly digitizing our world, instrumenting it and producing data about it. And I don't see any signs of this slowing down. So today, I'm going to talk about a few macro trends that we see at Radiant, some trends we've seen over the past decade or so. And I'm going to make the case that we've been launched into a golden age of data, but that the ways we've been funding and building technology are holding us back from benefiting from the data we have access to today. Now, also, if you'll indulge me, I had a very interesting conversation with George Dyson about Analogia and another book called Voice of the Dolphins on a podcast that I run that you can check out at texontext.net. But sorry to flog my podcast, but back to the regular programming. Now, our mission at Radiant Earth is to increase shared understanding of our world by supporting community-led initiatives that make data easier to access and use. Some of you at ESIP may be familiar with our stewardship of the stack metadata specification as an example of this. I don't want to talk too much about Radiant Earth, but if you are interested in learning about what we do, you can go to our website at radiant.earth. We use a motto/framework at Radiant Earth that guides our work, which is more data, more available to more people. And I think it's useful to guide this discussion here as well. We don't see data as a huge problem. At least it's not something that we're working on. We're not focused on it. You may have heard of surveillance capitalism or of the military-industrial complex. You are maybe less likely to have heard of the term MICI-MAT, which stands for the Military Industrial Congressional Intelligence Media Academic Think Tank Complex. This is a bit of a joke, and I also want to make sure that it's clear that I'm not making normative statements about these things. No matter how these complexes or concepts make you feel, they point to a really interesting phenomenon, which is that we as humans have created a very robust economy that supports the creation of sensors, instruments, satellites, rockets, networks, and compute infrastructure that produces data about our world. It's really astonishing. And if you look around, you'll see this infrastructure is everywhere. You see antennas and cell towers, network cables all over our built environment. And it's pretty interesting that we as a species do this. And a lot of the great work that we get to do in the earth sciences realm is actually just drafting off advances made by these complexes that are relentlessly producing infrastructure to produce data about the world. But the question is, are we making it available to people? And in particular, are we making it available to people who can do good things with it? The good news from our perspective is that making data available is a mostly solved problem from a technology standpoint. We see some pretty big macro trends that explain this and that we can thank for this. First of all, cloud computing has become commoditized. This is a huge deal. That's what we focus on a lot at Radiant Earth, is the fact that generic plain object storage services like Amazon S3, Azure Blob Storage, or Google Cloud Storage have been proven to be good enough to host data at just about any scale and very performantly. This is awesome. Competition among cloud providers puts downward pressure on price and upward pressure on performance and functionality. And so I think we can bet for the long term on object storage and serving data over plain HTTP and open standard formats as being a very effective way to share data. Along those lines, we've gotten very good at creating open file formats that benefit from the cloud, that are optimized for being stored in the cloud and accessed from the cloud. One of our main initiatives at Radiant Earth is called the Cloud Native Geospatial Foundation, which aims to help more people benefit from this fact. But please go to cloudnativegeo.org. You'll see a link at the top, and you'll see a guide that will explain to you a lot of the advances and trends that have been made in cloud native file formats. This guide was produced by our friends at Development Seed and NASA, and we're really, really proud to host that. Now, the third thing is that compute and open source tools just keep getting better and better. People can now build powerful tools to interact with data in browsers without needing to run any remote servers or install any software. And that's a function of people's local compute getting better and browsers becoming more powerful and more open source code being written that can be run in the browser. And this fact that we can do this stuff in browsers has a powerfully democratizing impact, particularly for people in low and middle income countries that may be less likely to have access to licensed software. And the combination of these things make just the plain web, the World Wide Web, an extremely capable platform for working with Earth science data, which is incredible. Now, there's a bonus thing that I wouldn't call a macro trend, but which is AI and the recent surge of interest in AI, and particularly large language models. I try really hard not to get too excited about new technologies. I want to wait until the dust clears to see what's real and what isn't. But it's very clear that large language models and some of the recent advances in AI and machine learning already are having a huge impact on our community. There are two main reasons for this. One is that it's dramatically lowering the cost of writing software. Lots of people who could not write code before now can. They can write good, functional, working code, which is going to dramatically lower the cost of creating new tools that allow us to work with Earth science data more effectively. The other thing is that people are already building interfaces that allow people to query geospatial data sets just using natural language. So a lot of the data science skills required just to ask questions of Earth science data are no longer going to be required. So I think that we're on the cusp of seeing many, many more, much more usable and much more accessible interfaces to put Earth science data in the hands of more people. And this is really, really cool. And then in addition to all of this, we're seeing a lot of breakthroughs in model training that are being transferred over to our community. We at Radiant Earth are the fiscal sponsors of CLAY, which is using a vision transformer model to create an open foundation model based on satellite imagery. And they're doing it all in the open. There are a lot of groups working on foundation models and things like this for Earth science data, and this is an awesome thing. We're very excited to see this. So now we're on to more people. This is the real challenge. Now, we do have reason to believe that all of the things I just talked about is putting Earth science data in the hands of more people. That's great. We're excited about that. We're happy about it. It's good that we're doing this, but we need to be much more deliberate about how we do it. And the truth is that this more people part of our framework is really hard. We know that it's not enough to just put data into the hands of people. We also have to think about whether or not these people have power, or whether we're putting data into the hands of the right people who can make change that needs to be changed. So we see two big challenges that we're working on. One is fundamental. We need to increase the size and diversity of the Earth science community and the Earth science data user community. And then in addition to that, in parallel to that, we need to ensure that the institutions that govern our lives are able to use Earth science data to make better decisions. We are not satisfied assuming that merely making data available will lead to better decisions and better policy and governance. This is a huge challenge. Now, we feel like we're pretty good at moving data over the internet, but one question remains, which is how do we do it consistently and reliably? Can we expect enterprises or governments to access Earth science data today and then also have access to it reliably tomorrow? Are we providing data that's indexed and accessible and actually useful right out the gate? These are very hard problems to solve. And we've watched many data portals and initiatives to share data come and go over the years. And I think we need to work a little bit differently and think more collaboratively about how we build these things. Because I think there are reasons why both the public sector and private sectors are ill-equipped to provide global access to data. So what you see here is a graph of investments in the Earth observation sector. Now, these are private investments. This does not include public sector investment in this sector. And what you can see here is a pattern that is known as a smiling curve. A smiling curve pattern shows up in a lot of value chains, where the inputs to a value chain and the outputs of a value chain receive a lot of investment, because that's where you can have intellectual property that you can make a lot of money off of, basically. The intermediary steps of getting from the input to the output are rarely funded as much. They tend to be much lower margin businesses, and they're very competitive. And this is one thing that we're seeing, and again, this is the commercial space sector, but I think that we can see this pattern in a lot of data value chains where we're happy to invest in the production of data, But we don't invest a lot in making data accessible, making it standardized, cleaned up, et cetera, et cetera. I know I'm preaching to the choir right here. What ends up happening then is that you need a lot of money to take that data and turn it into a useful product at the end. Our theory is that if we could produce better tools and infrastructure to clean up data and otherwise make it accessible, ready to use, reliably available, it would dramatically lower the cost of building applications on top of the data. I don't necessarily want the right side of this graph to go down. I want people to continue to invest in applications of data. I just want the dollars invested in that sector to go much, much further. So what I'm going to do now is talk about a few ways that we might be able to fund collaboratively the infrastructure in the middle here. Cooperative businesses are a huge part of the economy. A lot of people don't realize that they're all over the place. A lot of people think in terms of publicly traded corporations or a privately held corporation as being sort of the normal business model. But there are actually a lot of different kinds of business models. There are cooperatives that you may have heard of like REI, Ocean Spray, Land O'Lakes, Sunkist, Best Western Hotels is a cooperative, even the Associated Press is a cooperative. But my point here is that you can build durable businesses using cooperative models. This is not just a weird thing for hippies. Cooperatives are a big part of our economy. We interact with them all the time. One place that cooperatives often show up is in rural areas where there are few investors willing to invest to create utilities like power plants in sparsely populated areas. So in those communities, people will come together and they'll build their own utility, like a power plant. These are called utility cooperatives. And their goal is to provide the best possible service at the lowest possible cost to their members. And this is a model that we think about at Radiant Earth as we're designing durable data infrastructure. The most overt and obvious example of this is Source Cooperative. Source Cooperative is a tool that we're building. It is a data publishing utility that we think of in terms of a utility cooperative. The truth is that the cloud is still too hard for a lot of people to use. For very legitimate cultural, legal, or procurement-related reasons, simply putting data on the cloud in cloud-optimized formats is not easy for people. So Source aims to make that easier for people. That's why we're building it. And we're building it for our members, thinking of them as cooperative members, that we are relieving them of the burden of running or securing their own cloud infrastructure. And one of the things that we hope to accelerate with Source Cooperative is a true democratization of data publication. The world that most of us have grown up in is one in which we receive data from official data producers. It's been very much a one-way exchange. As you can see here, the idea of a trebuchet launching a massive boulder. We get the data from someone on high and we just take what they give us. Now, we know, however, that that's not how things actually work. Data users are always data producers. And even the people who give researchers grants are explicit about this increasingly. Government funders want you to take data from their official source, do some research, and then produce a derived product. But we don't have a great product on the market that makes it easy for people to publish derived products, especially at scale. And so that's why we're building Source. You can see here in the image the future that we want, where people are able to share data with one another. Now, joking aside, we actually have, there's a very common metaphor that I don't like, which has been common for a few years, which is that of a data lake, where there's this idea that there's a single pristine curated source of data where everyone can come and get their source of truth from. Now, I'm not entirely opposed to this concept, and it's not a terrible image, but I think what we really want and what we're trying to build is something more like a data rainforest, which is a fertile, diverse, and abundant ecosystem that everyone can contribute to and many more people benefit from. If we're successful at this, however, we need to be prepared for complexity and some degree of chaos. Now, I don't think we can tame chaos, but we can create things that help us navigate it, which brings me to another idea. Now, one powerfully democratizing technology that's emerged over the past few years is Stack. It is a simple specification. There's a good ecosystem of open source tools to support it, and it works. It's been adopted very quickly by many large organizations and software providers. Now, the result of this, though, is that there are a lot of Stack catalogs hosted all over the place, and no one can search them in a single spot. Now, very good and noble attempts have been made to map the Stack universe. We have stackindex.org, which at least lets you find a lot of Stack catalogs. And then we have EarthSearch from Element 84, which aggregates the Stack catalogs hosted in the AWS Open Data Program. And as you can see here, Microsoft's planetary computer also has amassed an enormous volume of disparate data sets and made them available via a consolidated Stack interface. But why shouldn't we try to create a consolidated catalog of everything that's out there? Stack makes data really nicely interoperable, but that's cut short by everything being hosted in different places. And while I hope that Source Cooperative will host a lot of Stack catalogs in the future, I don't want to say that the answer is for us to put all of our eggs in one basket and force everybody to store things in one place. I think it's a good thing that people host Stack catalogs in a lot of different services. Chris Stoner and I have been discussing this concept for quite a while, and I've come up with a name which is SuperStack, which would be similar to Stack Index, but it would require a bit more governance. And it would not only register Stack indices and catalogs, but it would create a single searchable interface to them, similar to Element 84's Earth Search, but including Stack catalogs from anywhere, and not just AWS. This would require ongoing maintenance. We'd need to receive inputs of new catalogs, we need to create a consolidated index of them, and we need to ensure they're accessible and up to date. This is the kind of work that many tool providers and research organizations would benefit from, but none of them has an incentive to build it and maintain it on its own for everyone else. So we are interested in developing something like this, and I want to hear from you, particularly if you have ideas of how we could fundraise collectively to make this happen. This is a solvable problem that I think we can do cooperatively. Now let's shift gears a little bit. I want to talk about endowments. I mentioned before that cloud computing has been commoditized. One of the great things about a commoditized and competitive cloud sector is that we can anticipate continued downward pressure on pricing for data, object storage, hosting, and bandwidth. If you believe, like I do, that serving data in open formats over HTTP is something that we'll be doing for the next few decades, we might want to consider using an endowment to make sure that data can be made durably available over a long period of time. Now, in case you don't know what an endowment is, a financial endowment it's a legal structure. So it's designed to enable long-term investments in certain purposes. If you can raise enough money for an endowment, you take the interest earned on that money and use that to sustain operations for a cause over time. Ideally, a nonprofit could exist in perpetuity off of the interest earned by an endowment if they don't spend too much of the interest that it produces every year. Harvard famously has the world's largest educational endowment of about $50 billion. In 2023, they took $2.2 billion of interest from that endowment to cover about a third of Harvard's operations. So you can do a lot with a big endowment. You just get free $2.2 billion every year. And one of the things that got me down this path was a conversation I had many years ago when I was at AWS. We had a government customer ask us if they could pay us a bunch of money and get data storage for 100 years. Now, that deal never went anywhere because I think at the time AWS was like 10 years old. And so no lawyers would agree to entering into a 100-year contract. But it did get me thinking is that what could we do to make data available over the long term? So it got me thinking that an endowment would be a better way to do this because I think we can make a long-term bet on storage costs going down. And if we got this right, it would ensure that not only researchers, but anyone, including entrepreneurs, insurance agencies, policymakers, whoever, could reliably access trustworthy earth science data for a very long time. And we could even potentially provide a service level agreement that gives businesses and their lawyers assurances that data will be readily available. And that would make them more likely to build things on top of it. I think we can do this. I think this is a solvable problem. Now, let me just run you through some silly math. For the purposes of this exercise, let's aim to store 10 petabytes of data for about 50 years. If you want to store a gigabyte of data in Amazon S3 in their infrequent access storage tier, it costs 1.25 cents per gigabyte per month. So multiply that by 12, and that's 15 cents per gigabyte per year. Now multiply that by 10 million, and you will get to $1.5 million per 10 gigabytes per year. So how do we get $1.5 million worth of interest per year? You have to raise a bunch of money. And so what the math tells me and I put this into calculator.net, highly recommended tool. It tells me that about a $25 million endowment would allow me to withdraw over $1.5 million yearly, assuming a 6% interest rate. This is close enough to cover storage costs and retail costs over 50 years. Now, let me make a bunch of caveats here. I'm ignoring bandwidth costs, which are much harder to predict, but would certainly add to these numbers. That said, if you spend this much money on AWS, you get discounts. I think any cloud provider will give you discounts if you're hosting this volume of data. So that would make these numbers go down. And I also think that it would make sense to cycle a lot of this data into cold storage, which could also save a lot of money. So these are, in some ways, liberal estimates. In some ways, they're conservative estimates because we can't predict bandwidth. But the point is that I do think that this is something that's somewhat predictable and something that we could come up with. Also, though, if you're like me, you're like, $25 million, isn't that a lot of money? Yes, it is. Radiant Earth does not have a budget like that yet. But it's totally within the realm of the possible. Again, Harvard has $50 billion endowment. That's 2,000 times the size of what I'm asking for. If we look at other conservation nonprofits, you can see the numbers. These are just yearly revenue numbers for these organizations. So $25 million is a fraction of what any of these other organizations do in 1 year. What I'm arguing for is that if we made a concerted effort to raise a one-time endowment, it could pay dividends for access to data over a very long period of time. Now, this is a very early idea. I've never talked about it publicly before. Again, I've been having conversations with Chris Stoner and a few other people about this. And I'm very interested in hearing from any of you if you're interested in discussing it. You can email us at hello@radiant.earth to talk about the ERA endowment or to talk about Superstack or anything else that we're doing. We do want to hear from you. And again, I just have to apologize and send my regrets. I really wish I could be there this year, but I just can't make it. But it's an honor to be here with you, even virtually. Thank you for your time.